This is the video for Unit 8, Lesson 2, Solving Systems of Linear Equations by Substitution. The goal we're going to have today is simply solving linear equations using our second method, substitution. This is a review of a skill that you learned back in Math 1 that we're going to see come up in this unit a few different times. So here are the steps that we can use for substitution, and again, lots of ways to do it. The idea is that we isolate one of the equations for one variable and then substitute it into the second equation. So we're going to essentially do substitution of an expression and then substitution for a value. So in the first example, this one is actually pretty straightforward. So we have two equations that are both y equals. We're going to pick one of these two equations, either one, because they both are y equals. And what happens is we're saying, like for the second one, for example, that y is equal to negative 2x minus 14. So if I was to write these side by side, but you don't necessarily have to rewrite them, I'm essentially going to take this expression of negative 2x minus 14 and substitute it into the other equation. So wherever I see a y, I'm going to put that negative 2x minus 14. This one, maybe a lot of you would have just thought to set them equal because it's essentially the same thing. But now we have an equation that only has one different type of variable. So we have multiple x's, but we no longer have y's. And now we're going to go ahead and solve this out. So I'm going to go ahead and add 2x to both sides. I have negative 14 equals 8x plus 18. And then we're just going to simply solve a linear equation. So when we solve this, we're going to get negative 32 equals 8x. X is going to equal negative 4. And to finish the system off, we do need an x and a y value. So we're now going to go ahead and take that value of negative 4 and substitute it back into either of the two equations. I'm going to use that negative 2x minus 14, but you can use either one. We're going to get 8 minus 14, and we get negative 6. So our solution for that first one should be negative 4, negative 6. So our x value is negative 4, our y value is negative 6. I'm going to have you try out. And for 2, we're doing the exact same thing. We're using substitution. So this one's a little different because you can see we have our two equations. They're not both y equals. We do have one of them that's already in a form where there's one variable by itself. In this case, we have x is equal to 4y plus 1. So in our other equation, wherever I see an x, I'm going to replace it with that expression. So if I rewrite it, it looks exactly the same, but in place of x, I'm writing 4y plus 1. We're now going to go ahead and distribute the negative 1 and simplify. These cancel out. We get negative 1 equals negative 3. This is a situation where our variables are no longer there. We get a numerical statement that's false because negative 1 does not equal negative 3. So what that means, this is actually a no solution. So anytime all your variables cancel out, but it's something that doesn't make sense, it's going to be a no solution. For number 3, we're going to find later maybe we would do this using elimination, but if you did want to use substitution for number 3, you might find with this one, we don't have a variable that's isolated by itself, but we could rewrite the second equation. Maybe I solve for x. And now these would be my two equations I can use. And then we're going to do the same thing as before. So this one has x by itself is the same as y plus 1. So in my first equation, I'm going to rewrite it, but in place of x, I'm going to write y plus 1. We're then going to go ahead and distribute. We get y plus 8 equals 2. So y is negative 6. And then substitute it back in. It's usually easiest to substitute into the equation that already has a variable by itself. So if I substitute that in, I would get negative 6 plus 1, or negative 5. So my solution is negative 5, negative 6. The next example we have is has a little bit more like what you would see on an SAT, right? So it's still doing substitution. It's just asking for something else at the end. It's just asking for simply y squared. So this might be one that you would see maybe even on a short response for an SAT because you're only putting in one value. And so this one's the same thing. If I look at it, I actually already have my x value. So if I was to like rewrite it the same way, I already have what x equals. X equals 4. So wherever I see an x, I'm going to put a 4. We're going to solve it out. And then we're going to get negative 5. So my solution to my system is 4, negative 5. But the question was actually asking for y squared. So y squared is equal to negative 5 squared. So your answer is actually 25. So to answer the question, we would have an answer of 25. And that's it. So if you have any questions, you can feel free to ask in class, sign up for T-Bolt time, or go to the center.